All right, so this is U6L5. Talk about factor theorem. Factor theorem is what we use to apply to polynomials to find factors. Okay, so before we do that, let's look at some integers. Something simple. I have 50 divided by 2. I'm going to get 25 with no remainder. That means that 2 and 25 are factors of 50. Whereas if I take 50, I divide it by 3. It's not going to go in evenly, right? I'm going to get a remainder. I get 16, remainder of 2. That means that 3 and 16 are not factors of 50. Okay, so when you get no remainder, they are factors. When you get a remainder, they are not factors. Same thing with polynomials. If I have q of x divided by p of x and I get r of x and I get no remainder, that means that p of x and r of x are factors of q of x. What's more is q of x is equal to p of x times r of x. That's exactly what factors mean, right? If you multiply them, you should get back to your original polynomial. An example, use the factor theorem to determine if x plus 1 is a factor of this polynomial. So they want you to find out whether it is a factor or not. If it is a factor, when you divide, you should get no remainder. If you get a remainder, then it is not a factor. So all you got to do is just put it into division, do the long division, and figure it out, right? Is it going to have a remainder or not? So I divide, I get 2x. Subtract that, I get that. Negative 3. Get that, subtract that, I get 0. Remainder is 0. That means no remainder. That means x plus 1 is a factor. However, 2x minus 3 is also a factor of that, right? They're both factors. And what's more, the original polynomial is equal to 2x minus 3 times x plus 1. Those two things multiply together to give you back your original polynomial. Example number 2, they tell you x plus 2 is a factor of this polynomial, this long one. They want you to find the other factors. So if you want to find the other factors, you just got to divide it, right? Divide, and whatever I get is going to be my other factor. So I get that, long division, subtract, I get that, negative 10x, blah, 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 subtract, negative 8, subtract. Do I get 0? Of course I should get 0, right? If I don't get 0, I know there's something wrong because they told me that it is a factor. So I should get no remainder. Anyway, so now I have x plus 2 and this new polynomial that I just found after I divided the quotient. After divided, I get that. Those two are both factors. But we can't stop there because this yellow polynomial here that I just got, the quotient, it's not factored all the way, right? You can factor it down more so you can get more factors. So I factor that. So here it is, right? The original factor is equal to these guys multiplied together. But I'm going to factor this guy some more because it's a quadratic, right? I'm going to factor that. And then I get 3x plus 2 and x minus 4 from this yellow guy here. So now I have all three factors. These are all factored all the way down. You can't factor them anymore. So x plus 2, x minus 4, and 3x plus 2 are factors of this guy. One more example here. Let's tell you 1, 0 of this is x plus 2. I mean, x equal to 2. What is another 0? Okay, they give you a 0 of this function. X is equal to 2 is a 0. What does that even mean? You know, so if they tell you 0, x equal to 2 is a 0, you have to use that to find a factor. What it is you want to make this equal to 0. So subtract 2 by both sides. I get x minus 2 is equal to 0. If it's equal to 0, it is a factor. So x minus 2 is a factor. Okay, once you have the factor, take that, divide, right? Divided by x minus 2. Boom. Long division, long division, long division, long division, long division. And I get 0 remainder. Oh, there it is now. I get these guys here multiplied together to be equal to my polynomial. But this guy doesn't give me a 0 yet, right? Not easily. So I have to factor it down more. Whoops. So here I factor that. I get x minus 6, x plus 3. So from these guys, I get that these are the zeros. So 2 is a 0, 6 is a 0, and negative 3 is a 0.